Let's look at this one. Therefore, very easy. The reaction between steam and iron. First of all, we must write down those reactants and products in terms of chemical formula. Steam, that is H2O in gaseous state. Iron is Fe, and all metal except mercury are solid state under room temperature and pressure. So the FeS is second reactant. And according to the equations about the product, there are two metal oxide, Fe3O4 given in the question, and it is a solid. And then hydrogen gas should be the second product. Up to this stage, all the species are represented in terms of their chemical formula, so we must add coefficient in order to balance the number of all the atoms. Say for example, here there are totally 4 oxygen atoms, here only 1 oxygen atom. So 4 must add here to provide 4 oxygen atoms. And also for the hydrogen, there are totally 8 hydrogen atom, so that we must add a 4 hydrogen here. And finally, only one species remain unbalanced is Fe. On the product side, there are 3 Fe, so on the reactant side, 3 should be added here. And this is the equation for the reaction between steel and iron. Let's go to another example about the reaction between calcium and water. Again, calcium, Ca is a metal, is a solid. Now, if we add with water is the liquid state, H2O. And then according to the previous equation, for the reaction between metal, that is KNa or calcium, when they react with H2O, the metal hydroxide will be formed. Okay? And also hydrogen gas. And the state for this calcium hydroxide is a little bit tricky, is because it is slightly soluble in water. So I use AQ here. And you may ask how to generate the equation for this calcium hydroxide. Just use this technique. Write down the cation and ion respectively, and then draw a cross, and then directly copy their symbol. And the charge on Ca, we add here. The charge of hydroxide ion 1, we add it next to Ca. However, it will lead to some ambiguity, is that if you read it directly, it means 1 Ca, 1 oxygen, and 2 hydrogen is in this compound. However, what we want to represent is 1 Ca2 plus with 2 hydroxide ions, so a brand can be added here. Well, up to this stage, all species are represented in forms of their chemical formula, and we have to balance it. If you count the number of oxygen, there are totally 2 times 1 oxygen here, so we need 2 H2O. And if you count the number of Ca and H2, is balanced already, so that is the final answer. Or if you really study what is happening in the reaction, Ca, when it reacts with H2O, maybe I draw the diagram here, with H2O, because we will finally need to form this compound CaOH2, so that we must need 2 H2O molecules, and then they will be split here. And these 2 OH group will combine together with Ca to form our first product, calcium hydroxide, and then these 2 hydrogen will bond together to form this H2 gas. So finally, we've got CaOH2 and also hydrogen. Is another way to think of the meaning of this equation. Is it okay? Well, for the metal's reaction with acid, there are 2 products, metal salt and hydrogen will be formed. Let's look at this one. For the metal now is aluminium, so Al. When it reacts with acid, H2SO4 here, there will be 2 products. First one is metal salt and hydrogen gas. The hydrogen gas is in forms of H2 is because hydrogen atom is not stable, it must form a diatomic molecule. And the question is how to generate a metal salt. If you have an acid, if you have an acid, how do you know the formula of the metal salts happen? Is that for this one, whenever we add with metal, it will actually use this hydrogen part to form this hydrogen gas. Okay? And then what's left? The anion, SO4 2-. And for aluminium, when it become stable to become a compound, it has an electronic arrangement of 2H3. So that it forms aluminium 3+. And the metal salt is actually the combination of these two ions. So again, draw a cross, directly copy Al, SO4 is here, and then copy their charge. The charge of SO4 is 2-, so the 2 should be next to aluminium, and then 3 should be next to the sulfate ion. And again, to avoid ambiguity, Al2 open bracket, SO4 close bracket 3 should be the formula. And then we'll just put it inside the equation. And up to this point, all species are converted into their chemical formula, and we can start to balance it. So, say for example, for aluminium, it's 2 aluminium is liter, okay? And then for sulfate ion, we can actually treat it as a whole. On the product side, there are totally 3 sulfate ion, so we must need 3 H2SO4 to provide the concerned amount of SO4, 2-. And after the addition of these 3, we need 3 H2, that is totally 6 hydrogen atom. And here is the result. Okay. And finally, we just need to add back the physical state. For all the dilute acid, they are aqueous in state. For all the metals, except mercury, they are solid in state under room temperature and pressure. And hydrogen, obviously, is a gas. The most important thing here is that what is the state for aluminium sulfate? We have to check for the solubility of it inside water. It's because for the acid is aqueous in state, it means in this environment there are lots of water. So we have to consider whether this aluminium sulfate is soluble in water or not. And you just check the solubility rules table, and it is soluble. So the state should be AQ.